Hey everyone, it's Mr. Montgomery again. Today we're going to be going over alternating currents and circuits. Okay, so we already went over batteries, we went through electrical currents and what they are. So we already know that direct currents are batteries only, and that we use the abbreviation DC when we're talking about it. And electrical currents are a consistent flow of electricity going through any kind of circuit or material. Alright, so after today you're going to be able to tell what an alternating current is and how it works in a circuit. And also, you're going to be able to tell what a circuit is and the different kinds of circuits and how you can check them and fix them and all that kind of fun stuff. So, I kind of just said this. So let's see who is paying attention. What does DC stand for when we are talking about electricity? So you can either just pick one and think of it, or point to the screen, whatever you prefer to do. Does DC stand for District of Columbia, direct current, or deadly current? It of course stands for direct current, right? DC, direct current. So, other types of electricity, we have alternating current. So we already know direct currents through batteries. Alternating current is from the outlets in every single home. This is an electrical current that periodically changes direction. So it will start flowing through one side of the cable and then kind of reverse itself and flow through the other side. So it kind of works back and forth like a seesaw. Okay? And also, every single one of these outlets in your home is 120 volts of electricity. So don't stick anything metal or shiny in there. It's going to hurt. Alright, and there's also some alternating current precautions because it is a consistent flow of electricity flowing through your house at all times. We need to make sure that we're being safe. So every single home has one of these. This is a circuit breaker. I'm sure you guys have all seen one of these before. You can turn off every circuit in your house this way just by switching flipping one of these switches. Turning them off and on and all that kind of stuff. But I gotta say, don't mess with them. If you really want to see the bad stuff that can happen when you play with circuit breakers, go on YouTube and look up a video about arc flash. Okay? ARCFLASH. It scared the bejesus out of me. I don't like electricity. I don't trust it. And that video is one of the videos that made me scared of electricity. Alright, so at your house, your alternating current of electricity is connected to a circuit breaker. A circuit breaker is a reusable safety switch that breaks the circuit when the current gets too high. Fun little story about me. Years ago, I was told by someone that I needed to fix a light switch in a house. So me not knowing anything, and I was only about 19 years old, I really knew nothing about electricity. I started unscrewing the switch that needed to be switched out. And I did not turn off any circuits in the circuit breaker, which is super, super dangerous. And then by the time I got halfway through, I saw a huge spark shoot out from the wires behind the wall, and I almost got electrocuted. Every single light in the house went out, and I almost blew a fuse. It was very, very dangerous, not a smart choice. Do not play with electricity, ever. It's super, super painful when you do. So, because of this circuit breaker, I didn't get electrocuted, and as soon as that surge of electricity sparked where I was fixing that light switch, the entire circuit breaker shut off, so we had to go downstairs and flip all these off and back on again. Every single one of these switches. So that's why it's there. It's to make sure that if you're in danger, that you're not going to stay in danger. Alright, also another precaution of alternating current is a grounding rod, or to make sure that the current is grounded. And when we say that a current is grounded, we are not saying that it's in trouble and being sent to its room without supper. We are saying that any extra currents that are flowing in your home are redirected out of the house into the ground where it is absorbed and dispersed throughout the earth. And this actually saves us from so many things. If you did not have your house grounded, then every time you went to go try to do laundry in that huge iron cage that's in your house, guess what? You would get electrocuted, or at least you would get shocked, because all that electricity would be flowing throughout all those appliances that need a lot of power. So we make sure that the extra currents flow out of the house and into the ground, where they are diverted away from us. So right here it says grounding is when charges are able to flow directly from the circuit to the earth, which is what this conductive rod helps us do. Okay, so what do you think would happen if the electricity in your house was not grounded? Let's see who is paying attention. Would it be nothing? Would it be you could get electrocuted by appliances and other parts of your home? Or would it be you could blow a fuse? Well, you would probably get shocked by a lot of things. We do not want extra currents flowing through our house. All right. And what could happen if a strong electrical current is not grounded? Well, if you go to YouTube and look up, oh gosh, what was it? It was something along the lines of pool not properly grounded, and you will come across this news report where some poor children touched this metal pole right here in the pool. They were electrocuted as soon as they touched it, because the electrical currents that were being supplied to the pool were not properly grounded, and they were flowing through all these metal things that are in the pool, and they are highly conductive. The pool water is full of different chemicals and stuff that is also conductive. So these children, when they touched it, they completed the circuit, connected to ground, and they were electrocuted, and they could not move. It was super, super scary to watch. So that video is on YouTube, and you can see the really bad repercussions of not taking electricity seriously and not grounding any electrical currents. And that's exactly what it says over here. If a strong current is not grounded, then the metal attached to that current is now electrically charged and can harm anyone who comes in contact with it. So if you go on YouTube and check out that video, you will see a lot of people get in contact with this conductive pole, and a lot of people get shocked. It's really, really upsetting. So just note trigger warning before you go see it, okay? Okay, let's see if you can name just one thing in the classroom that you go to that uses an alternating current to work. Close your eyes and think about the classroom you go to for science. Or actually, you know what? Any classroom. Can you think of one thing from any of the classrooms that you go to that use an alternating current? Did you just think of something? Well, one thing you could type in if you were typing is a smartboard, right? Also, any clock is usually plugged in using alternating current. Also, if you have a fan in your room, pencil sharpener. We have a lot of stuff in our schools that use alternating currents all the time. Oh, and also, this is such a big one. How did I miss this? The lights. The lights in the room use alternating current to work. Okay, if you go to YouTube and type in difference between alternating current and direct current, it is a super, super helpful video. It shows some really good graphics of how alternating current works compared to direct current. And they actually show the reverse flow of electricity when a light bulb is using alternating current. It's really, really cool. I highly advise you guys to go check that out. Okay, so now that we know the difference between AC and DC, and I'm not talking about the band, we now have circuits that we can learn about, right? We have two different kinds of circuits. So the first circuit that was ever made was a series circuit. It is very basic. It just flows from the power source. The switch is optional. It goes straight from the power source to whatever it is attached to. For this example, it's a light bulb. It comes back around and completes the circuit at the other end of the power source. For a parallel circuit, It starts the exact same way. The current leaves the power source, it comes back around, and instead of going through one path, it actually has two different pathways to connect. And I'm going to show you guys exactly why that is so important when we are using electrical circuits. So, first, our series circuit. So series circuit only has one pathway to take for the electrical current. So that means if I were to take this first light bulb out, if I unscrewed it, totally take it out. You might not have realized this, but that light bulb, when it's plugged in, completes the circuit. The electricity is flowing through the wire, into the light bulb, up, across this coil inside, back down, and then flows back through the original wire. And then goes back into this light bulb. The reason why this is so important to know about is because this is what every circuit used to look like. And then if this light bulb is broken and that coil on the inside isn't connected, the entire circuit doesn't work. The other light bulb will not light up. It sounds crazy, but I promise you, that's exactly what happens. I'm sure you can go on YouTube and find videos of basic circuits being disconnected. You take that light bulb out, it doesn't work. And that goes for anything that disrupts that pathway. So if you're going to flip that switch, nothing will flow through. If you accidentally sever this, it won't go through. Or even if you just unscrew this second light bulb, that will also stop the current, and you'll see the first light bulb go out. It's insane. It's really cool to see, though. Now, if you want to see a very good example of what would happen in this situation, you can go watch the movie A Christmas Vacation. It's an 80s movie with Chevy Chase, and he puts 25,000 lights all over his house just to find out that something is wrong. So the end result of this will show you exactly what would happen if one light bulb goes out in a basic series circuit. So let's see who is paying attention. Let's do a little quick check. So if you were to have a whole bunch of light bulbs connected through a series circuit, like the Christmas lights in the video we just kind of passed over, what would happen? Or why would they all go out? Would it be because they were just too old, the lights were not plugged in, or one light bulb was out in that circuit? Why would all 25,000 lights not work? I'm hoping you guys are thinking about one light bulb could have been out to disrupt the entire circuit. And just think, 25,000 light bulbs to check every single one of those Christmas lights? That's going to be such a pain. But we have a solution these days. Now, Christmas lights use a parallel circuit, where we have multiple pathways for the current to take. You see it leave the power source, it comes up, the electrical current will flow down and up at the same time to hit both lights, and then come back at this centerpiece and flow back around to the power source. This way, if this bottom light bulb goes out or is broken, the top light still works and completes the circuit. Or if the top light is broken or doesn't work, then the electricity can still flow through the bottom pathway and complete the circuit still and stay on. So it really helps prevent the disruption of electrical current. And that's it for alternating current and circuits, guys. So I hope that this video is helpful. I hope it helped you understand the basics of AC electricity and also circuits. So that's it for today. Hopefully you guys will stop by and see the next video when I post it. Hope you guys have a great day, and as always, I will see you next time.